Hello and welcome to another Ginger Mathematician video, and today I'm going to go through iGCSE Advanced Vectors. I did a similar video on mensuration with advanced mensuration, and I thought I'd do exactly the same for vectors as well. Now if you're really not sure about vectors, again what a vector is and doing those basic calculations with vectors, then please do check out my Udemy course on vectors. It's completely free and that will get you up to speed on what you need to know for iGCSE vectors in general. But I thought I'd take some more advanced questions. I've had a lot of requests for a video like this, so you can go through this nice and carefully. Right, let's get started. So we have a diagram that shows a triangle OAB. So we've got O here, A and B, and a parallelogram over here, so OKAL or OALK. And the position vector of A is A, and the position vector of B is B. So that's already marked on here. What it's basically saying here, this word position vector, we're going to talk about this a lot in this video, often confuses students, but all a position vector is, it's the vector from O to A. So O to A is just vector A, and the vector O to B is just B. The O here is just the origin. It's the center point where we're working from. Now K is a point on AB, so this straight line here, such that the AK, the ratio AK to KB is 1 to 2. So what that means is, remember with ratios, if we do 1 plus 2, we get 3. So that means a third is represented by this section, and 2/3 is represented by this section from B to K. So putting in all that key information just to help us when we actually work out what the question wants us to do. And what it wants us to do is work out the position vector of L. So remember, the position vector, just like I mentioned here, we're starting from O, so we're looking for OL. Now, in order to go from O to L, we have a couple of options. One option is to go from O to A and then go A to L. So we could do that, or we could go O to K, okay, plus KL. So we can take either of these roots up here in order to work out the problem. Now, because this is a parallelogram, so this is an important word in the question, it basically means that the vector OA is going to be the same as KL. Okay, they're the same length and direction. So I can actually write this in as well, that this vector is also going to be A as well. So it means I can take either route and it's not really going to make much difference. Okay, so this is the way we try and use this sort of retrograde thinking. I want to work out OK, that's really important for the question. Before I can work out OK, I need to work out, well, to go from O to K, I need to go O to B and B to K, for example, or O to A and A to K. So I need to work out this vector BA or AB. So I'm going to have to, in some shape or form, work out this vector. I'll put it in blue here so you can see this nice and carefully. And I need to work this out, whichever direction that we go. I'll just take this direction, so from B to A. So how do I go from B to A? Well, to go from B to A, I can go from B to O and O to A. So I'm going to write that in, B to O and O to A. Now the vector B to O, because I'm going against the arrow, is going to be minus B, and O to A, I already know this is plus A. However, in order to work out this O to K, I need this section of my vector here in order to do O to B and B to K. So if I want to work out the vector BK in that direction, remember I wrote this down earlier, it's 2/3 of the entire vector, 2/3 of BA. So it's going to be equal to 2/3 of minus B plus A, and so that's equal to minus 2/3 B plus 2/3 A. Okay, so we're working through, now we're working forwards rather than working backwards. Now I can actually use this to work out OK, which was important from what I wrote earlier. So to go from O to K, okay, sorry, that joke is so bad. Then we go from O to B, and then we go B to K. Now O to B, I already know, that's just equal to B, and B to K is what we worked out earlier, which was minus 2/3 B plus 2/3 A. Now we're going to collect up some like terms. Remember, this is one lot of B, so 1 minus 2/3, that's going to be equal to 1/3 B. and then 2/3 A stays as it is. We collect up A's separately and B's separately as well. Now, OK is not the answer we're looking for. Remember, we're looking for the position vector. We're looking for OL here. So to work out OL, just like I did above, we need to go from O to K, which we just worked out, plus KL, which we already know. So we have then 2/3 A plus 1/3 B, and then we've got this vector K to L, that's just equal to A. Now remember, we've got 2/3 A here, we've got a whole A here, so 1 plus 2/3 is 1 2/3, or 5/3 A plus 1/3 B, which is going to be our final answer. Make sure you got your squiggles on your vectors. That's really, really important to make sure indicating it's a vector quantity and not a number or scalar quantity. So you can have a look at the mark scheme here. Again, for all 4 marks, we've got our answer, and you can see where you pick up those method marks as well. Right, on to question 2 here. So they like their position vectors, yeah? OA and OB, so we're given that X and Y. And OD, so the vector O to D, is equal to 3/7 X plus 4/7 Y. And we need to calculate the ratio A to D and D to B, kind of backwards to some of the questions we're going to see today. Okay, so before we can really discuss this, I think we just need to work out our vector A to B. Notice that's always a very standard thing to do, the so-called long way to go around and find this vector. So A to B is A to O and O to B. So that's equal to minus X plus Y. You can write down minus X plus Y straight away once you're used to these kinds of questions. So in order to work out O to D here, we then just go O to A, and then some fraction of this line here, some fraction of AB. So let's just give that a number. Let's just call it K. So K lots of AB. We don't know how long we need to go along the line. That's what we're trying to work out here. So we have O to A, that's equal to just the vector X plus K lots of what we just worked out, which is minus X plus Y. Now we can expand the bracket here. So we just get X plus minus minus kx plus ky. Again, we can rewrite this slightly, so we can factorize out an x, so we get 1 minus kx plus ky. And we're told this vector OD, as is seen in the question here, is equal to 3/7 x plus 4/7 y. So in order for this to be true, again, k must be equal to 4/7 in order to get this as 3/7. So our ratio here, so this is 4, the whole thing needs to total to give us 7. So therefore this needs to be 3, because 4 plus 3 is 7. So we have our ratio here of 4 to 3. Careful, not 3 to 4, but here 4 to 3, because we have this extra position vector in here as well. Okay, so you can check the answer here. Again, quick 2-mark question. Again, it's working backwards to what we've actually kind of seen already. Okay, and now we've got a bit of work with magnitude and subtracting vectors. Again, a bit more on the easier side. So first of all, we want to work out P minus Q. If you've watched my Udemy course, I go through this in quite a lot of detail. So we've got 2 minus 1, and then we have 8 minus 4. So remember, 2 minuses here. This is what you have to watch out for to not miss a mark out. So minus is a plus, so we get 3 at the top and 4 at the bottom. And now it wants us to work out the magnitude of this vector. So this is something we'll talk about in later parts of the video. And remember, if you want to work out the magnitude of the vector, you want to do Pythagoras. So we put this into the Pythagoras formula. And again, this is quite nice numbers. If you spot the answer straight away, really well done. So we get square root of 9 plus 16. That's equal to root 25, and that's equal to 5. Again, if you notice that Pythagorean triple of 3, 4, 5, really well done. You can pop that straight in. As you'll see in the mark scheme here, again, you get 1 mark for some idea of putting 3 and 4 together. Right, on to our next question. So we have a trapezium, not a parallelogram this time, so a trapezium, so you have to be a little bit more careful. O is the origin, OR is A, and OP is B. Okay, so we've got our position vectors here. And the magnitude of RQ, so let's look at this vector at the top here, is 3/5 of the vector OP. Now we know OP is equal to a whole B, so the top here must be equal to 3/5 B. This is a very common technique that I'm doing in these questions. Before I even look at the question, I try and fill in as much information as I have, so then when I come to the question, I've already got that information there ready for me. Now we need to find the vector PQ in terms of A and B. So we want to go, and let's put this in a different color. So here we are, so going from P to Q. And we're going to have to take the long route round, I'm afraid. So if we want to work out PQ, then that's equal to P to O. So we're taking the long way around here, P to O, O to R, and then R to Q. And by putting in that extra information, we can just put in all the information we have. So P to O going against the arrow, minus B, and we're going with the arrow, O to R, so plus A, and then we've got 3/5 B. Remember, this is minus 1B. So this simplifies then to A, and we've got minus 1 plus 3/5. That's going to give us minus 2/5 B. You need to be good with fractions when you're working with these kinds of vector question. So let's pop that in. We have A minus 2/5 B. Nicely done. Now this next question, a lot of people ask me about this kind of question, so do pay careful attention to this. So when PQ and OR are extended, they intersect at some random point called W, and we want to find that position vector of W. So we want to find OW, whatever that's going to be. So what does this look like? So P to Q is extended, so imagine it going up like this. And what else is extended? OR is extended. So at some point, and you can probably agree with this, it's going to meet at, resume that slideshow. It's going to meet, oh great, I have great fun with this. Okay, it's going to meet at some point W at the top. Now you probably agree here that if I do this in a different color, it must be just some vector just with A in it, because we're just going along this line. Again, we're just making the vector bigger or smaller, so we're changing the magnitude but not the direction. So this vector must equal to something A. We just don't know what that something is. Now, the way to think about these kind of problems is actually think of it in two different ways. So we know that OW, the vector O to W, is equal to some K times A. We know that from what I just described. However, we could also take a longer route. We could take the route O to P and then P to W. So we could take the vector O to P and P to W. This is where part A is very important for part B. Now the vector O to P is equal to B. And so this vector PW is some multiple along this line, a multiple of this PQ that we worked out before. So let's call this like some kind of T, we don't know what this T is, of that vector PQ. So let's write that in. So some T times PQ. So PQ was A minus 2/5 B. And let's just multiply out and collect stuff. So we get B plus T lots of A minus 2/5 T of B. Thinking why we're doing this, but you'll see in a moment. And then we collect up A's and B's together. So we have TA, and then we've got a 1 here, and we've got minus 2/5 T. We don't know what T is at the moment. B. So there's two ways of describing OW. Either the first thing, just some multiple of A, and that means 0B, there's no B involved. Or TA, a different letter, plus 1 minus 2/5 TB. If these two things are true, then that means that the K must equal T, first of all, and that 0, most importantly, is equal to what I have here. We're doing basic equating coefficients. We use this a lot at A level as well. So what I can say is this 0 at the top here is equal to whatever's here. So 1 minus 2/5 T. That gives us a really easy equation to solve. So we get 2/5 T is equal to 1. and therefore t must equal 5 over 2. Again, this is an advanced video. I'm not going to go through that in much detail. And remember, I also said that t is equal to k, which is what we wanted to find. So our answer here will just be the position vector, OW, is just equal to 5 over 2a, like so. These questions come up a lot at the top end where there's AA star questions, and if you want to get those A stars specifically, these are the kind of questions you need to kind of get your head around and practice. So there's the mark scheme for the two things that we have already done so far, and you can check the mark scheme as well. If you're interested in working with me to get those really top grades, then do check out the A-Star Maths Masterclass. Again, I put a link to my website in the description, where I'm taking 5 students and I'm seeing if I can get them to all A-Star standard and hopefully some world or country toppers as well. If you're interested in that program, do check out the website down below. Right, let's continue. So we've got that word magnitude again. Told you that would pop up again. Of this particular vector is equal to 29, and we want to find the value of k. Remember, as soon as we say the magnitude of a vector, we want to Pythagorize it. That means we have the square root of 20 squared plus k squared, and is equal to, and we're told in the question, 29. So essentially, this is just an equation to solve, but the key thing is setting up very nicely like this. So first of all, this square root is kind of ugly. What's the opposite of square rooting? Well, squaring both sides. This cancels, giving us 400, 20 squared to 400, plus k squared. If we square the 29, we get 841. Then we're going to minus 400 from both sides. That gives us k squared equals 441. And then the opposite of squaring is square rooting on both sides. That's going to give us k is equal to the square root of 441. Please be careful at this point, because the answer is plus and minus 21. Whenever you square root, you get 2 answers, so be careful. Please do put the plus minus 21. You don't want to lose 1 mark for not putting minus 21, because that could also be the case as well. Okay, there's the answers and the mark scheme over there. Right, let's move on. So we have S is a point on PQ such that PS and SQ is in the ratio 4 to 5. I like to write this out as fractions. Remember, these two add up to 9. So PS is 4/9 and this part is 5/9. And we want to find OS. Again, standard question, but you need to be getting these right. First thing I'm going to do is work out P to Q. So the vector P to Q, we've done this quite a lot now. We go against the arrow first, so we get minus a, go with the arrow plus b. Then we want to find the vector PS. So remember, that's going to be 4/9 of what we just worked out. So minus a plus b. So that gives us minus 4/9 a plus 4/9 b. Hoping at this point in the video you're doing these questions and then watching afterwards. And then we want to find the vector OS. So the vector OS is simply the vector OP and then PS. So we combine them together. O to P is just A. We have minus 4/9 A plus 4/9 B. Remember, this is one lot of A, and that's going to give us our final answer of 5/9A plus 4/9B. Just like so. Again, if you can do this in 2 minutes, that's really good. That's the speed you want to work out with these kinds of questions. Okay, there's your mark scheme. And let's move on to a parallelogram here. So we've got OA and OC, given P and Q is the point on AB such that AE, EB is 3 to 1. So again, we've got 3/4 and 1/4. So I'm going to write that on my diagram. Notice how similar some of these questions are. This is why you need the practice. OE, again, almost identical here. So the first thing I'm going to do is work out O to A to E. Because this is a parallelogram, I can say that this is going to be Q as well. So what do I want to work out first? O to A and A to E. So I'm just going to do O to E. Again, don't try and overcomplicate these. So we've got O to A, and then we've got A to E. So that gives us P. Sometimes you're trying to trick yourself and go, it's more complicated than it is, yeah? And then just 3/4 Q, yeah? We don't even need to work out the vector BC here, yeah? Because it's a parallelogram. So then we just get P plus 3/4 Q. Yeah, it's a 2-mark question. It's probably not going to be too much to do. Okay, on to our next question, slightly different. So in diagram, O is the origin, OT is 2 lots of TD. Okay, that's slightly different. So OT is 2 lots of 2D. So if this is 2/3, this has to be 1/3. So what's saying here is if you double TD, you're going to get OT. So that's useful to put in, slightly differently formatted. And M's the midpoints are halfway. OC is C and OD is D. We need to write those in. So this is C and the whole thing here is D. And find the position vector of M again, just changing the language slightly. So we're looking for OM here. So to work out OM, we need O to T and T to M. Okay. So I'm just thinking how we want to work this. Right, so first of all, we need to work out T to M. In order to work out T to M, we need T to C. Now to work out T to C, we're going to go backwards, so we'll go against the arrow, so minus 2/3 lots of D, and then add C. Okay, and so T to M, remember, is the midpoint, so we want half of what we just said, so minus 2/3 D plus C, so that gives us then minus 1/3 D plus a half C, and then we use the formula at the top, so OM, it's going to be OT, which is 2/3 D plus what we just worked out, so minus 1/3 D plus a half C, and that gives us 1/3 D plus a half C. Probably put it in alphabetical order, so a half C plus 1/3 D, like so, for 3 marks. The whole point of showing this video is that you're building up your skills and your speed with this as you're going along. So once you've done 5 or 6 questions like this, you start seeing the patterns and you can get very good at very complicated questions quite quickly. So here's the mark scheme for you. So a half C plus 1/3 D. If you're interested in more vectors, you can't get enough of vectors, and you've already checked out my Udemy course in the description, and you've gone through this video, you can check out my original iGCSE vectors video, which is doing pretty popular, almost 100,000 views at this point. Then do check it out right in front of you, because this will give you more vector practice, a bit more of a variation than just the advanced questions I've done in this video.